Yeah, that's fine. Yeah. Okay. All right, so I'm going to try to record this today. I've been having trouble with that, but I think I've got everything on my computer resolved. So hopefully this will record, and then I can post it, at some point in time today if you need to review it. Okay, so we are going to be talking about what a function is, and basically the definition of a function. This is what was in our book, so I'm going to read that definition and kind of go through what it really means and kind of get you straight on that. So basically a function, it's a relationship between two things. Typically we're going to be working with numbers, but it doesn't have to be numbers, where every input leads, and here's the key, exactly one, that's the key, output. So every input only gives one output. There are times when an input will give more than one output, okay? So basically what we're going to be talking about, the most part, is the domain of a function. That's just the first element. So what we're going to be talking about is those are x values. You want to fill in, what I need you to fill in. So when I'm asking you to find the domain of a function, you're looking for what the possible values of x are, okay? The range of a function is the set of second elements and a Cartesian plane. That means like we're graphing, okay? We're just doing setting up a graph. So the range is the set of y values like that. Okay, so let me explain what that definition of a function really means. And what you can look at is what we call a mapping diagram. And the idea, like there's three mapping diagrams. The domain would be all of the first numbers. These are the inputs right here. And then the outputs or the range, it would be that. So what you're looking for is, just ask this question. Does this go to only one number? Does everything here go to one number? And if you look at that, the -2 goes to one number, and so does everything else, okay? So they can't branch out and go to more than two. So that is a function. That is an example of what a function is, okay? All right. So the domain's real simple. The domain is going to be all of these first values. So the way you write this is like this. You use what we call set notation. So you do, that's a brace, and then just list them, -2, -1, 0, 1, and 2, like that. That's how I want you to write the domain. It's just typically we just list the elements, okay? The range is all of the y values, okay? So that would just be these things right here. So again, for the range, what we're going to do is just kind of write that as use a brace, and then we just say -8, -1, 0, 1, 8, like that. Okay, so that's what a function looks like. It's just every member of the domain goes to only one thing. Okay, that's what you want to kind of get straight. Okay, and domain and range is real simple for students typically. Okay, look at the next one. Just look at all the inputs. -2 goes to one number. That's a check. -1 goes to one number. That's good. 0 goes to one number. That's good. 1 goes to 1, and 2 goes to 1. That is a function. That's what a function looks like. Okay? So what we get is we're going to say again, yes, that's a function. Okay? And then the domain, we list all of the inputs, which would be the x values. Typically, you want to do that in order, although it doesn't really matter. It's just the best way is put that in order. Yeah. Mm-hmm. Okay, I'm glad you asked that, because that's not what the definition says. Okay, what it says is everything here only goes to one thing there. It doesn't matter that two different things went to 4. Okay, it's just, and you'll be more clear when we look at this example. Okay, I think. Okay, all right, but that's a good point. Okay, so the range is these numbers, and again, just put it in order: 0, 1, 4, like that. Okay, so that's what that is. Okay, what do you all think about this example? Do you think that's a function, yes or no? That's a no. How come? It's going to one, you got elements going to one more place. And this is, Carla, what you were kind of maybe a little confused about. This is not a function because the 1 is going in 2 places. Okay, if you have things that branch out in two or more directions, not a function. That never happened here. In fact, we could have just one number in the range, and they could all be going to that one number, and it's still a function. Okay? So that's not a function. Does everybody understand why that's not a function? Okay? All right, so let's write that down. No. We still are going to, talk about the domain, because you can have a domain of a relation. This is a relation. It's just not a function. So the domain would be 0, 1, 4, 9. And then the range would be, let's see, it doesn't really matter what order, but I'm going to go -3, -2, -1, 0, 1, 2, and 3. Yeah. No, but it's like it's preferred that you would put it. If you're doing something on WebWork, it depends on how it's programmed. Okay, it may be programmed to take it in any order, but just develop the habit of putting it in numerical order. Okay, that's the idea. Okay, all right. Any question on that? All you really look for is, if something in the domain is going two or three directions, then it's not a function. Okay. So here's one last one right here. This one would be a function, basically for the same reason. These are your inputs, 1, 2, 3, 4. These are your outputs, A, B, C, D. It's just, hey, they're all going to one thing. Okay, that's the idea. Okay. All right. So go ahead and go to the next page. And I want you to just take a few minutes to fill these out. You can kind of do these yourself. If you want to compare answers, you certainly can. I'll walk around and see if you got any questions. Generally, this goes pretty smooth for students, as long as you understand that function definition. Domain and range is real simple. And the information in this section, there's not a lot of information in this particular section. Okay, so we'll go ahead and run through those. Okay, so I think everybody signed in. You already got your handout, right? I'll add that on because I saw that you've been officially put that in class. Okay, I don't think you'll have too much trouble. I don't think time is to be that way. Yeah, it's the same thing. It's just that -2 has one thing. So the numbers of the domain are all different. It's just written in a table instead of we call these a mapping diagram. They're still asking the same question. You already know the vertical line test? Okay. Yeah, okay. A lot of times you might remember stuff like that. And I am going to try to record everything that I teach today. I think I've had this memory overload issue on my computer, and hopefully I've got that resolved. So that's the only one. No, that's good. Okay. That's good. There's only one of them that's a no, that I see anyway. Okay. And that last one is just kind of writing that in a slightly different way. Okay, it looks like most all of us are done. I'm going to go ahead and just put the answers up here, and then you can check and see if you got these right. Okay, so number one was a function. Your domain was 4, 8, 12. Your range was 0, 10, 20. Okay, I think everybody had that. I didn't see anybody get the first three wrong. So example 2 is, yes, it's a function. So basically the idea on this is these three guys, they all have a crush on one girl. That's a function. Okay, that's okay. All right. And then the domain is Ken, Carl, and Lewis, and the range is Kathy. Okay. Now, example 3, I like to teach it this way. I think it's kind of funny. You might not think it's funny, but Jerry's a bad boy. He's got a crush on 3 girls, so that's not a function. Okay, you can't do that. That's a bad thing to do, right? So that's not a function. Okay, idea is that's going to 3 different places. Okay, and again with this one, you'd have Jerry and then Abigail, Barbie, and Jill like that as your range. I think everybody got that right. Okay, so this one. Now, really, you could write it like this if you want to. You don't have to do this, but one thing I did is I just wrote, here's my domain, here's my range. My range only has 2 and 4, and every input goes to 1 output. So that's a yes, and domain, I wrote it in that order, and then the range, you just put 2 and 4. You don't put 2, 4, 2, 4. You don't repeat yourself. You just need a 2 and 4 there. Okay, so if you need to correct anything on them, then you need to do that. Okay? All right, anybody have any issues with that? I think we all got them right. Are we good? Okay, all right, very good. That's what we mean by a function. Okay, so we'll go ahead and go to the next page. Vertical line test is the same thing, but it's looking at things visually. So it's important that you kind of understand how these things go. So we use a vertical line test to look at a graph and see if the graph represents a function or does not represent a function. So if any vertical line passes through exactly 1 point, you want to fill that in, okay, then it's going to be a function, okay? On a graph, every time you do a vertical line, it's only got to pass through the function in 1 point, okay? And then if you can find a vertical line that passes through 2 or more points, then it's not a function. And you want to understand why that is. Students have no problem doing this. A lot of times I don't understand if they can't tell if they really understand it or not. But the idea is, like, these are all functions, okay? And, you know, if I take vertical lines, no matter where I draw the vertical line, it only goes through 1 point of that function, okay? It doesn't go through more than 1 point. So that would be a function. This thing right here, again, anytime you draw a vertical line, it only goes through 1 point, okay? And the same thing with these here. You know, you don't really have to draw anything on your paper. You do this more mentally. But all of these examples right here, those are all functions because they only touch the function in one place. Okay, does that make sense? Okay. Now, when you go over here, well, it's totally different. Okay, and the idea with this is with this one right here, this vertical line goes through 2 points. And this is what you just got through doing. The same input is 5, right? You have 2 different outputs. You have an output of 2 and an output of -2. That's why it's not a function. The vertical line test basically is testing for one x value to see if it has 2 or more y values. All right, does that make sense? Okay, it's really the fact that the same x gave us 2 different y's, okay? Same thing happens here on this circle. Notice that 2 has 2 different y values. That fails the vertical line test, okay? And I like to put these on here because you want to focus on it's the fact that you get more than one y value for the same x that makes it not a function, okay? All right, any question on that? Okay, students generally don't have much trouble with this. So let's go ahead and just do some of these together, then I'll let you do a couple of these real fast. Okay, on part A, what do you think? Yes or no, a function? No. How come? Because you can find a vertical line that goes through 2 points. Okay, that fails the vertical line test. That's not a function. How about the next one, B? That's a yes. Every time you draw a vertical line, it's only going to go through 1 point. Okay, so that's a yes. That's what a function looks like. Every input, every x has exactly 1 y. How about C? What do you think on that? Yeah, okay, yeah. Every vertical line goes through 1 point, so that's a yes. And then how about D? Yes or no? That's a no, okay. This is something, if you're going to go to higher math, this thing is called a cardioid. If you're going to take pre-calc, maybe next semester or trig, you learn about that. And like as a musician, we have what we call a cardioid microphone, which actually has that kind of pickup pattern that's modeled by this mathematical function or relation. It's not a function. So you might see that if you ever look at a microphone and it has that little kind of heart-shaped thing on there, that's called a cardioid microphone. Okay, just thought I'd throw that out there. That's a no, okay? All right? Okay, go ahead and just quickly, I'm not even going to check your work on this, but this is kind of what I'm wanting you to do on this. Like on this number 10 on the next page, is number 10 a function, yes or no? Okay, yeah, yes. And the reason is it passes the vertical line test. So I'm just going to let you guys do this, just give you, probably only takes a minute to do this, and then go down to, when you're done with that 10 through 15, plot the points. I want to just see if you guys remember how to plot points okay, and see if you think that would pass or fail the vertical line test, okay? You raised all of us, right? Yeah. I haven't seen you in a long time. Yeah. So you need to probably come up and talk to me after class, okay? If you do that. It's going to be real important to do that, okay? Okay, thank you. You got all your handouts over there? Okay. And I do want to kind of walk around and just look at your points. I'm not going to, I will go over how you plot points, but I'm just curious if we remember, okay? Sometimes students remember, sometimes they don't. And when you plot your points, you just kind of looking at, is there a vertical line that goes through 2 points? You know, yes or no. It's kind of the same way. Okay, we're on that 3.1. I think we're on page 4.
I know I messed up.
That's okay. I just wanted you to try, and you can redo it. I'll be reviewing that. Okay. Because we haven't really talked about graphing yet. I just wanted to kind of throw it out there and see what we remembered on that. You can always think of graphing a point as like the first number is just this way. How far you go this way.
Okay.
The second number, the y value, is how far you go this way. X is a measure of left and right. Y is a measure of up and down. Okay? That's what we mean by that. Okay, I don't think anybody had any trouble with the 10 through 15. Students just don't ever have any trouble with that. It's not that difficult. I do want to go over the points and just kind of do those. So just check that you got these things. So number 10 was yes, it passed the vertical line test. 11 failed. Number 12 passed. 13 passed. 14 failed, and 15 failed. So just make sure you got all those things. Okay? All right. Thumbs up, thumbs down, vertical line test. Okay? That'll be one of the easier things you learn in college algebra. Okay? Really. Okay? Now, for plotting a point, let me just go over that because not all of you may remember how to do that. You know, basically when you plot a point, X is this way. That's what X is. It's a measurement of left and right. Y is a measurement of up and down. So the way I do this is like this. You start at the center and you would go left 4 and then you would go up 5. Okay, so you're just making sure that your X value is -4, your Y value is 5. Now you should do this. If you didn't do that, you should put the letter A by that. You should really label these things, okay? -3, 0, that would mean that you go to the left 3, but if Y is 0, what does that mean? It means you don't move up or down, right? Okay, we call that an x-intercept, which we'll talk about stuff like that a little bit later in the class. And then the next one, you would be going left 4 and then down 5. Okay, so that's where C is located. And then the next one, well, that's just in the center. You don't move at all. So that's D. We call that right there the origin. You can write that down if you want to. I mean, that's not a vocabulary word I test you on, but we call that the origin. Okay. And then -3, 3, this would mean we go left 3 and then up 3. So that would be where point E is. Point F would be right 1 up 4. And then G would be right 2 up 4 like that. Okay, so it's real simple. That was invented by Rene Descartes in the 1600s. It took that long for human beings to figure out that kind of thing, but it revolutionized math, and it was a huge revolution. By the way, that's how your cell phone works. That's how your TV works. You have pixels on your television that are represented by a coordinate system. So that's what happens at every instant of time when a television or your computer screen has all of these pixels, and there's thousands of them in the modern world, and it just turns them on a certain color. It just goes fast, fast, fast like that. Okay. In the old world, like when the video games came out when I was in junior high, it was like Pong. They were boring as they could be. All they could do is just have a big basketball that's a square that would go like this. Okay. Why are they so good now? Because our coordinate system can have millions of little pixels on it. Whereas in the old days, maybe your computer screen had 100. Okay, that's what makes the difference. So that's an incredibly important human invention that Rene Descartes did. All right, well, is this a function? What did you come up with? No, because there's a vertical line right there that goes through 2 points. Here's another one that goes through 2 points, so that's a no. Okay, all right. I just wanted to throw out the plotting points to make sure that you got a little quick review on that. Okay, the next thing we're going to do is evaluating a function. And if you're not real familiar with function notation from your background, well, we're going to be dealing with functions throughout college algebra. If you're going to take pre-calc and calculus in the future, functions is what it's all about. That's the background. So we spent a ton of time doing functions in this class. All right, so this is the notation. If we have f parenthesis x, we just read that as f of x. Okay, that just means that is the symbolism for a function. And we typically always use f, g, and h. You can use other letters, but f, g, and h are the most common. Okay, and if you had like f of t, that would just mean that t is the variable, not x. You had g of z, that would mean z is the variable and so forth. So this is just notation, that's the language. So when we evaluate a function, like in this example 1 part A, you've got 2 things. You're given your function, f of x is x squared minus 3x plus 1. You want to find f of negative 2. Now what this means is that negative 2 is what x is. So what you're going to do is everywhere you see an x, you're just going to replace it with negative 2, and then you're going to do your arithmetic. That's what it means to evaluate a function. So if we have f of negative 2, just do this. And one thing students oftentimes don't do a good job on is deal with negatives very good. So this is a personal recommendation that makes a difference. You know, before you plug the negative 2 in, you should always have parentheses where your variable was. You're kind of creating a spot to put that in. And if you don't put those parentheses, it'll mess you up sometimes. Okay, so it's a good habit to develop. So what I'm going to do is just put the negative 2 in here, negative 2 in there. Now it's all about arithmetic. Okay, you guys got good calculators, but my recommendation is that you can do most of these problems without a calculator, because we live in this world, because people are so reliant on calculators, that's why people have trouble with factoring in this day and age. Because mental arithmetic is not as good as it should be, in my opinion. All right, so negative 2 to the second, what's that? Negative 4 or positive 4? Positive 4, because that's negative 2 times negative 2. This part right here, think of that as 2 negatives. Negative 3 times negative 2 is a positive, so just put addition 6 like that. Then bring down the 1, and then that would be 11. Okay, so that function, what it really means is negative 2, 11 is a point on the graph of that function. X is negative 2, the y value is 11. That's what that means, okay? All right, next one, you start getting into decimals. That's kind of where it's kind of helpful to use a calculator. So this time I'm saying g of t. So again, when we do g of negative 0.25, I'm just going to write down 6 parentheses to the second minus 4 parentheses plus 6. Okay, again, it's good to use those parentheses where your variable goes. If you don't develop that habit, there's lots of places where that's going to mess you up, okay? So we got this, negative 0.25 just pops in. Okay, now you could use your calculator on this if you want to, okay? So it goes like this. If you did that on your calculator, negative 0.25 times itself would be positive. So that would be, I think, 25 squared is 625. So I think what will come out on your calculator is 0.0625. Check me on that. Am I right? Yeah, I think I am. Okay. All right. If I think about it, I'll show you all how to do that, how I did that in my head. All right. It's kind of a cool thing to show students. I'll show you in a minute here. Okay. If I quadruple a fourth, this whole thing right there would be plus 1. Negative times negative is positive. Again, check with your calculator if you need to. 0.25 is a quarter. 4 quarters is a whole. Okay, that's how I do that. Okay, now the 6 times 0.0625, I don't want to mess with that. Okay, so I'm going to go ahead and get the calculator out on that. Okay, 6 times 0.0625 is going to give this, so that'll give 0.375 plus 1 plus 6. Okay, so that would be 7.375 like that. Okay, I think students would be wise to learn to do as much arithmetic in your head as you can. All right, now I'm going to go off on a tangent here, okay, just because I think it's cool. You may or may not think this is cool. I don't know. I'm going to teach you how to do this in your head. Write it down if you want to, or just watch, okay? It's really a slick trick, okay? All right, here's how you do it. Take the first digit and then do 2 times 3 in your head. 2 times 3 is 6, right? Okay. I'm not going to finish the problem. I'm going to do this. Do the next one. Do 3 times 4 in your head. That gives 12. Next one, do 4 times 5. That's 20. Next one, do 5 times 6. That's 30. That's how you get the first part of that. Okay. Now what you do is they always end in 25. So that's the answers to those squares. Now this is just a little trick. If you're doing like something, a 2-digit number that ends in 5, you can do it in your head. Okay. Here's one more example. Just one more. Okay. Like if I had 95 to the second power. What's 9 times 10? 90, and then stick a 25 at the end. Do you think that's cool? Some people are shaking their head. Okay, did anybody know that? I didn't think anybody did. Okay, it's just something that, you know, when you're a mathematician, you learn all these kind of things.
Does it work with other numbers or just?
This is just a trick that works for a 2-digit number that ends in 5. I wish it worked for everything, but it doesn't. It only works for that case. All right? And I think it'll work for anything. Like if you did 23 squared, you would do 23 times 24, whatever that is, and stick a 25 at the end. You can try it on your calculator. I think it works. Okay. Anyway, just wanted to show you that because I think it's cool. Okay, so let's work a few more things out, and then we're gonna. This is not a very long section, so we won't spend a lot of time on this section. The next one says h of z is z minus 8 over z plus 8. Okay, so just plug it in. So again, I'm going to write this as parenthesis minus 8 over parenthesis plus 8. I wish more students would develop the habit of putting parentheses where that variable goes. All right, now here's what happens on this problem. Your numerator is negative 16. Your denominator is 0. What do we know about that? It's not 0. It's undefined. It's not even an imaginary number. That's a good guess, but it's undefined. Okay, you can't divide by 0. Okay, I'll show you one way to remember this, and then I want to talk a little bit about why. Okay, you cannot divide by 0. The answer to this problem is undefined. Okay, all right. So here's one way to remember this, because I asked that question. I think you said your name's Saeed, right? Yeah, okay, I was close, all right? You said 0, you're getting it backwards. So if you have 0 divided by a number n, that's 0. But if you have a number divided by 0, that's undefined. Okay, if you're somebody that has trouble remembering that, this just spells the word no. Okay, so it means no, you can't divide by 0. This says on means you can get an answer. Okay, just something I came up with one time, trying to see students over and over again get those things backwards. Now, here's the reason why. Okay, now let me show this to you, because most students don't know why you can't divide by 0. Okay, and just watch this. You don't have to write this down. 8 divided by 4 is 2. How do you know it's 2? How do you check your answer? You do 2 times 4 is 8, right? That's what you learn and when you're learning division, when you're in a 3rd grade or whatever, right? Okay, but what if you had 16 divided by 0? Okay, what if you think the answer is 0? Does that check? 0 times 0 isn't 16. So 0 can't be the answer, okay? Well, what else do you think? I mean, let's try another answer. Maybe 1's the answer. Does that check? 1 times 0 is 16. In fact, nothing checks. So if you divide 16 by 0, you'll never find a number times 0 that'll give you 16. That's why it's undefined. Okay, does that make sense? You can't divide by 0, okay? If you want to think of it this way, if I came to class with 16 cookies and there were no students, could I divide my cookies up if there was nobody here? No. Okay, all right? So that's why you can't divide by 0, okay? So those are little fundamental things that are going to pop up. So yeah, you can sometimes have a function that you evaluate and you get something that's undefined. Okay, so let me do a couple other things. So we're just learning how to evaluate functions. All right, the next one, part D, what we're going to do is we're going to have f of negative x. And again, write down parentheses every single place where there's an x. Like that. Try to develop that habit. All right, what will happen on this now is all we do is we replace all of the x's with negative x. Okay, we just plug that in like that. Now what we have to do is we have to work this out now, okay? So what is going to happen if you have negative x to the 3rd? What does that mean? It means negative x times negative x times negative x. What do you get? You get a negative answer and you get x to the 3rd power, right? Okay, so that becomes negative x to the 3rd. If you multiply out an odd number of negatives, it's negative. If you multiply out an even number of negatives, it's positive. Okay, those are fundamental things that are going to pop up. Okay, then we bring down the minus 3. And if you do negative x to the 2nd, that means negative x times negative x. Well, that's a positive x to the 2nd. So we're just going to write down x to the 2nd. Okay, and then finally right here, how do you handle this? When you subtract a negative, we've seen that all semester. How do you handle that? That becomes adding. Subtracting a negative is the same thing as adding. So that's plus x plus 7. Okay, that is your answer to your problem right there. There isn't anything else to work out. So what you're doing is you're just replacing x with negative x. And one thing I want to show you is this, okay? You can catch on to all kinds of tricks with math. See, that was an odd exponent, right? What happened? Negative answer. This was an even exponent. That negative 3 stayed the same. X is x to the 1st. Odd exponent, sign changed. Okay, that's what happens. Okay, so you want to work that out, but over time you can learn little tricks that can help you figure that out too. Okay, all right. So the next one is going to be, we have g of t. We're going to find negative 3 g of a. Okay, so write it like this. We're going to have negative 3 and then draw like a bracket, and then inside the bracket put the function. We're going to have 6 times something to the 4th minus 4 times something to the 2nd plus 1. Okay, so what we're going to get then is you replace all of the t's with just an a, not a negative a. So if it's a negative a, you have to think about it a little bit. If it's an a, all it's going to do is change the variables. So what you're going to get is negative 3 times 6a to the fourth minus 4a to the second plus 1. And then what you want to do is just do a distributive property through that. Now, distributing, that would be negative 18a to the fourth plus 12a to the second. And then negative 3 times 1 is minus 3. So this would be your answer to your problem. Now, there's a lot of these things you can do in your head. I mean, you can certainly do the g of a in your head. All that did was just change the t to an a. But that negative 3 is a part of what we were trying to find, so that has to be distributed through that then. Okay? Are we okay? Okay, all right. Now let's go ahead and I'm gonna have you work out the rest of the problems here. And you probably want to work in groups of 2 or 3 just so that you can compare answers and see if you're getting similar answers on these. Okay? A lot of it's arithmetic, so if you can do your arithmetic using your calculator correct, that'll help you. Okay? What I've got here, just kind of the first 4 here. I think everybody's probably got the first 4 okay. So number 1 was 19. Everybody had that. Number 2 was undefined. I don't know if everybody did the arithmetic right. I think some of you had that numerator wrong. You should have negative 9 over 0, but you can't divide by 0, so that's undefined. Number 3, you would end up with 0 over 0. It seems like everybody had that. That one's also undefined. It doesn't matter what the numerator is. The denominator is 0. That means it's undefined. Okay. The last one's real simple. All of the x's change into a's. So you get 8a to the fifth minus 9a to the fourth plus a minus 5. Okay. Does anybody have any problem with those first 4 or any questions on those? Okay, I think we're good with that. And I kind of just threw the 6 and 7 at you. So let me display the last 3 problems here and kind of show you what I did here. And some of you got that last one okay. But you want to check and see number 5. The answer I got on number 5 is negative 16z to the fifth plus 18z to the fourth minus 2z and then plus 10. Okay, have we got that? Okay, all right.
You can drop the F's. You don't have to keep the F's in there.
Keep the what?
Thought that you would originally have to multiply everything by 2F.
Well, you want to change all the x's to z first. Okay, there's kind of an order that you want to do that. So, what I did is it just becomes 8z to the fifth minus 9z to the fourth plus z minus 5. Okay, then you want to multiply everything by negative 2. You want to distribute that through, so you've got negative 2 times 8, negative 2 times negative 9, and so forth. Okay, so you got to plug the z in first. Does that make sense, Daniel? Okay, all right. All right, now the next one, watch this carefully. These next 2, see, what I'm giving you on this is I'm giving you what f of x is. Okay, so I'm telling you that f of x is 7. So what happens is this thing, the 7 plugs in there. I don't tell you what x is. I tell you to find x when f of x is 7. So you end up with the equation 7 equals x cubed minus 1. And then solve this equation like this. You add 1 to both sides to get x to the third equals 8. Okay? And then what you can do on that is you really just do the third root of both sides. So the third root of anything to the third is just itself. Okay? So that's how you would do that. So you would end up getting 2 as your answer. But again, it's not x is 7, it's f of x is 7. Does that make sense? I can't tell. Okay, the problem said plug in 7 for f of x, not x. Okay, all right, and then the next problem is the same idea. I give you that g of x is 10, so that goes in there. The 3x squared plus 20x plus 3 stays the way it is. That's equal to 10. Now, what I've done here is this is quadratic equation. You know, basically I got one side equal to 0. That's why I subtracted 10 from both sides. So I got 3x squared plus 20x minus 7. And your choice on this quadratic equation would be either to factor it or to go the quadratic formula. Okay? Now I went ahead and factored this. And so what happens on this, your first term is 3x and x. Your last term is 7 and 1. And this is a kind of factoring problem that I think probably over half of the class might not be comfortable on still. And this is something that we're going to work on throughout the semester. You have to get really good with your factoring. See, this middle term is negative 1x. That outer term is 21x. We want that to add up to 20x. That's why I have the plus and the minus like that. Okay, and you have to play with the numbers until you get that. And then once we get those factors, we can set each factor to 0 and solve. So you would get 1/3 and negative 7 as your answer. Okay. All right. So I just sort of threw those last two problems at you to kind of see what you did with that. Do you guys understand, first of all, why I plugged in the way I did on the last two? I can't tell. Give me a sign or what? I can't tell. Okay. Now it's solving the equation, okay? See, if I just give you something like find f of 2, that means x is 2. I didn't give that to you, okay? I gave you what the entire function was. So you left the x alone and solved the equation, okay? All right, is there a question?
So number 7, the negative, the negative 1/3. No. Is it negative? No, just the 1/3.
Okay, my factoring, I had 3x minus 1 and x plus 7. So I set each factor to 0. And when I take 3x minus 1 equals 0, then I'm adding 1 to both sides, then dividing by 3.
Oh, that's
okay? Because once you get your factors, set them to 0 and solve both equations. Then you got it, okay? All right, well, let's go ahead and take a break till not quite 10 minutes, more like 8 minutes. Come back at 1 o'clock, and then we'll get started on section 3.2. I'll leave these up if you need to copy anything on that.